it's important that we know how to name ions, because we're going to have to name ionic compounds. Ionic compounds are held together by electrostatic charges. It's just a fancy way of saying that opposite charges attract. And that cations have lost one or more electrons and have a positive charge. Those are our cations. They got a positive charge. Whereas anions have gained one or more electrons. Thus they have a negative charge. So metals lose electrons and become cations, whereas nonmetals gain electrons and become anions. And so knowing our periodic table and how to use it is important. Looking at that stair step, the elements to the right and above that are our nonmetals, and those are what are going to get a negative charge and become our anions. The elements to the right and below, these are going to be our metals. They're going to gain electrons. They're going to lose electrons, hence become a positive charge. They become our cations. So there's some things to remember in that when we're looking at the main group elements. The main group are the ones on this periodic table that have an A as part of their group name, the Roman numeral plus an A. And that the 1A, the alkali metals, these are always plus 1. The 2A, the alkaline earth, these are always plus 2. Column 3A becomes they're always plus 3 when you make an ion. And then what's called the D block, or the transition metals, and they can have varying charges. And that will come into play as we go through this lesson. If we look over the nonmetals, the halogens, when they make an ion, a negative ion, an anion, they're going to have a -1 charge. The group 7A, the 6A rather, the chalcogens, oxygen, sulfur, selenium, tellurium, they're going to get -2. The 5A, if they're going to make a charge, they'll be -3. And so the 1A always have a +1 charge. The 2A always get a +2 charge. 7A, the halogens become -1. 6A, the chalcogens become -2. And 5A become -3. So these are important things that you've just got to know, memorize. And also remember the group 3B, scandium, yttrium, they're always +3. And the transition metals and the D block, it can have varying charges. If you haven't talked about we'll talk about electronic configurations a little later in this course, or maybe we won't, depending on which course that you're taking. This middle block is sometimes referred to as the D block. So let's predict the charge on these elements when they form ions. So where is strontium? It's element number 38. It's an alkaline earth metal. It's in group 2A. It's going to get a +2 charge. Sulfur, element number 16, is a chalcogen. It's a nonmetal. It always gets a -2 charge. Yttrium, element 39, is in group 3B. It's a metal, loses 3 electrons, so it always gets a +3 charge. Bromine is a halogen in group 7A, a nonmetal. It always gets a -1 charge. Selenium, element number 34, is in group 16A, and so it's going to get a -2 charge. Why they get these particular charges is beyond the scope of this particular lecture at the moment. but it does have to do with electronic configurations and trying to get to a noble gas configuration. Those transition metals, those elements in the D block, they can get varying charges. We need a way of telling what that charge is. We'll use something that's known as the stock nomenclature system. Nomenclature is just a big fancy word that means rules for naming. So let's write the names of the following ions. Now what we're going to do, before we do that, actually, let's talk about how we write a stock nomenclature for an ion, its name. What you do is you give the name of the metal, and then give its charge as a Roman numeral in parentheses. So the name of the metal and the charge is a Roman numeral. So cobalt plus 2, you write cobalt, and then since it's plus 2, you put Roman numeral in parentheses. The parenthesis is important. It's part of the name. So cobalt 2 plus is cobalt, parenthesis, Roman numeral 2, close parenthesis. Mb3 plus is niobium, Roman numeral 3, without Roman numeral 3 being in parenthesis. So now let's do these examples. Fe is iron. So iron plus 2 is going to be iron 2. Versus the ion that's iron 3 plus, which we'll write as iron 3. The 3 being in parenthesis, and the 3 is a Roman numeral. Pd is palladium. And here it's got a plus 4 charge, so the 4 goes as a Roman numeral in parenthesis. Molybdenum is Mo, and here it's got a Roman numeral of plus 6, meaning it's got a plus 6 charge. So that's how we write the name of cations when they have the possibility of more than one charge. If they have only a single charge, you don't use the Roman numeral. So like sodium is in group 1, when it gets a charge, it's just plus 1. So you just write that as the sodium ion if you were to give it a name. Occasionally you might see it as sodium 1, but since it's only ever 1, all the chemists I know just leave that 1 out. Not trying to be confusing, just trying to be efficient. When we're naming ions that come from nonmetals, we're going to form anions, because these will have a negative charge because we've gained electrons. So what we're going to do is write the name of the nonmetal, the element, but we're going to use a suffix IDE. So N3 minus is nitride. Nitrogen becomes nitride. O2 minus, oxygen becomes oxide. So we drop the last syllable and add the suffix IDE. So fluorine becomes fluoride. Notice this U before O is fluoride. It's not OU, it's not flouride. Se2 minus is not selenium, but now it's selenide. Phosphorus 3 minus becomes phosphide. And bromine minus, bromine becomes bromide.